In this segment, I think everything that we will see will be completely obvious to most people almost everyone who's used Java. So this will be C++ functions, but if you've used Java methods, this will all be very familiar. How do we call a function? You just use the name, and then in parentheses, you put in the required number of parameters. So in this case, these are arguments. And you'll see something about the notation of the terms, arguments, and parameters. If you've ever been confused about what's what, well, I'll try to explain it in this segment. So if you look at some of the earlier code, you probably remember that total cost returns a double value, so a double precision number, and this is what's going to be assigned to this variable named Bill, which should be a double. Remember, in C++, it can be an int and it'll work. It'll just throw away the fractional part of the result that total cost returns. So number and price are called arguments, and you can have anything. You can have variables like these seem to be, although we can't really tell. One of them could be a constant, but even though by convention all constants are all uppercase, you could still have, one of these could be a constant. You can be, so basically you can have literal constants like 2 or -5, variables like these seem to be consts, expressions, so like number times 5 or price times 3, things like that, or some combination of these. So these are called arguments or actual arguments because they contain the actual data being sent. So I'm going to skip this example. It's not super complicated. You can take a look if you wish, but we sort of did this with the average function. I try to keep it simple, simpler than this particular example, but definitely take a look in the book. Okay. So remember that a function declaration is information for a compiler, or it's informational for what the compiler needs to know, which is the return type of the function, the name of the function, and the list of parameters and their types. So that's important. The actual parameter names is not needed, and we did that. We took away the names, and as you saw, everything still worked. Okay, so this is just the declaration itself. You don't need names over here. So remember, if you have a semicolon, that means definitely this is a declaration or a prototype. All we need is the types of the parameters and the return type and the name. Those are important. Okay, so now let's take a look at what exactly is a parameter versus an argument. Now, the whole problem is that these terms are very often used interchangeably. That is, people say parameter when they really mean to say argument, and people say argument when they really mean to say parameter. That's the problem. So parameters are what you have inside a function declaration or inside the definition in the header. So when you have the list of parameters in the definition of a function, those are parameters. Okay? In the function call, those are arguments or actual parameters. So that's, this is part of the reason why it can be confusing. I tend to stick to, or try to stick to, the notation that these things are parameters, and where you call it, so I'm calling, let's say, this function total cost with these two things. These are the arguments. These arguments go into the function and they are called whatever the parameter names are. Let's go quickly take a look. The parameter names are, well, actually I'm going to zip back up and take a look in here. The parameter names are number parameter and price parameter. So just to repeat, the parameters are what you see in the function. When you look at the function itself, you see parameters. When you take a look at where it's called, you see that at the function call, you see arguments. These are arguments. These are parameters. Okay, so try to remember that. If you forget, it's actually no big deal. It's just that some people are very particular and they like to distinguish between parameter versus argument. And so, yeah. So, can a function call another function? Sure. You did that in Java. You can do that here. And main, as we saw, can call the average function, can call the random or rand function. The only requirement is that before you call it, you have to have a declaration of the function. So for now, it's pretty simple. We did that already. We had to have this declared up here. And later on, what we'll do is we'll write our own functions and put them into a header file of our own, and then we'll pound include our own header files. And so we will see that if you forget to pound include, you'll get this strange error message saying, what does this mean? And then what you really need to do is, all you need to do at that point is you have to pound include your own header files. So what this means is we could put this into a separate file, pound include it here, and yeah, that will work. Let's try it out. So I'm going to create a new header file called my functions.h is good. And inside this part, I'm going to paste that. Okay, actually, what I meant to do was copy this and paste here. Alright, so I'll save that. And now, instead of this code, I will just do a pound include, and I'll use double quotes here, my functions.h. Okay, and if everything works, we should still be able to compile. Okay, so it worked. Let's just double check and make sure by introducing an error. We can do that. Let's just say, alright, we'll change the name of it. Alright, save it. So we're introducing an error just to double check. It's always a good idea to do these kinds of things. Now we do get an error message. Good. So, we're just double checking. These are the kinds of things you do to make sure that this is actually working. We fix that error now, save it, recompile, works fine. And then the last thing we want to do is run it. Okay, that's good. So now you see a situation where you've put the declaration in a .h file, pound included it, and we have the definition here. They don't have to be in the same file, the declaration and the definition. And we could have put this in a completely different file called x.cpp, and then we have to do something with our make file, so I'm not going to get into that right now. We'll do that later. Okay. So there's one situation where a function, remember a function can call other functions. There's one situation where you can even call itself. A function that calls itself is called recursion. If you want to do this, you have to really be aware of how to use recursion. Recursion is possible, but by default, if you just have a function that calls itself, program will crash. You have to implement it in a certain way, and so we will talk about those things later when we get to recursion, and we'll use recursion quite a bit in this course. You can have a function that returns a bool, any valid types. A bool is a valid type, and so you can have functions that return bool. You just have to make sure that they return only true or false. Okay, so this is pretty straightforward, and since most of you have used Java methods, I'm guessing this is no problem. How do you declare void functions? You just say void and then function name and the name of the parameters. No big deal. You've done this in Java, so let's move on. And so you can set up a void function, in this case show results. All it does is print out something with some setting of formatting, things like that. So it's none of these things will produce an output that you need to return, and therefore that's why you can make this a void function. So for void functions, notice you'll have no return statements. You can have a return here actually, and that's perfectly fine. And sometimes people do it. It's completely optional for void functions. If you return a type, if you return something other than void, yeah, you definitely do need a return statement where you return something which is compatible with whatever type you're returning. In this case, it's void. You can put a return statement by itself, return semicolon, or omit it completely. How do you call void functions? Basically the same way, except you don't assign the return value because there is no return value. And so, yeah, you guys have used it in Java. Okay, what exactly does a return statement do? It transfers control back to the calling function. And for a return type other than void, you must have a return statement inside the function. It's typically the last statement in the function, but you can also return from the middle of a function. Return statements are optional, so you don't have to have a return statement for void functions, but you can have multiple returns. Let's say if you check some condition, if x greater than 0, return, else do something else. Now that's perfectly fine. You can have multiple returns. So I want to quickly give a heads up to the students who are also in 235 at this point. In Csis 235 object-oriented programming, we spent a lot of time on preconditions and postconditions. So this is going to be a requirement in all of the code that you write, and so some of you may want to check with me and see what's involved in preconditions and postconditions. This book that we use, Savage, is a lot more lax than the book that we use in object-oriented programming, that is Nino and Hosh. In that object-oriented programming book, preconditions and postconditions have to be Java-compatible Boolean expressions. And I do explain during that course that those kinds of rules are, the rules that they have in Nino and Hosh are pretty hardcore, and out in industry, they are a little bit more lax, and they're a little bit more like the Savage book. However, to keep everyone sort of on their toes, to make sure that we can do the best possible job that we can, I'm going to require that preconditions and postconditions in this course follow the rules that we used in the object-oriented programming course. That is, they have to be valid Boolean expressions in C++, not English language statements like this. Okay? All right. So that said, let me just say briefly what preconditions are. Preconditions are conditions on the parameters, and postconditions are conditions on what the function, in this case, will have done. So typically that's a return value, but it can also be, let's say, some other things that might be changed by this function, and they have to be as much as possible valid C++ Boolean statements. So more about this later, and you can talk to me about this too.